This is my trigonometry project by me, Casper, about my object. So I used a bike tire wheel and I taped a coin to it and I spun the tire in a counterclockwise motion. I allowed the wheel to make 2 full cycles as I recorded the time and the height of the coin throughout both of those cycles. The wheel had both a width and height of 2 feet, and the radius of the wheel was 1 foot. Here's a picture of the wheel I used with the coin taped to it to follow along when it made its cycles. So here is the equation, data table, and graph. So the equation was y equals 1 sine 2 pi over 10 x plus 1. And here's my graph. You can see that 1 full cycle was 10 seconds. And you can see the amplitude is 1 foot. So how I found the amplitude, stretch, and period. I found the amplitude by taking the radius of the wheel and converting it into the amplitude of 1 foot. I was able to find the vertical shift by recording the ground level, which was the bottom of the tire, and finding out where the coin started. The coin started at 3 o'clock on the position of the tire, which was 1 foot off the ground, which made the vertical shift +1. There was no horizontal shift for the coin, and I was able to find the period by recording how long it took for the coin to make a full cycle on the tire. Here are separate questions that I created about my sine graph. Where does the coin start? So the coin starts at 0 seconds and 1 foot off the ground, or 0, 1. From which times is the coin above 1.75 feet? The coin is above 1.75 feet from 1.35 seconds until 1.65 seconds. Also, these values plus 10 seconds as it's on its next cycle. You can find these answers to the questions by either looking on the graph or creating a triangle by creating a unit circle. And at which time is the coin at the minimum height? The coin was at the minimum height at x equals 7.5 or 7.5 seconds, and also 7.5 plus 10x, or 10 seconds, 20 seconds, 30 seconds on the next cycles.